Did you ever notice the city sirens sound a little sharper and closer on a blazing summer day? Well, that's not just your imagination, it's physics. In the first 3 seconds, I'll show you why heat makes sound zip across the air faster. Sound is a vibration that travels through molecules. The speed of those vibrations depends on how fast the molecules are moving, exactly what happens when the air heats up. On a cold morning, the air molecules are sluggish, so sound takes more time to hop from one atom to the next. On a hot afternoon, those molecules are dancing faster, pushing the vibrations along at a higher pace. This means the same siren can feel nearer or clearer when it's warm. Let's break it down with a quick, simple formula scientists use. V equals 331 plus 0.6 ton. Here, V is the speed of sound in meters per second, and T is the temperature in degrees Celsius. On a chilly 0 degrees Celsius day, sound travels about 331 meters per second. On a scorching 30 degrees Celsius day, it speeds up to roughly 349 meters per second, almost 20 meters per second faster. That difference might not sound huge, but over distance, it adds up. If a crack of thunder rolls across the sky, you'll misjudge its timing and distance unless you account for the temperature. Think about a plane flying really high where the air is cold, versus a jet crashing into a heat streak over a desert. The roar of the engines will reach the ground slower in the cold because the sound waves can't move as fast. That's why airport runways have those big, tall sound walls engineering the air around the jet's noise to keep it from reaching people on the ground, especially during night takes-off when the temperatures plunge. Another everyday example is when you clap in a hot kitchen versus a cold room. The sound from your hand pulse will be felt slightly quicker, and you might even hear it echo differently. The warm kitchen's air acts like a supercharged highway for vibrations, pushing the sound to bounce against walls faster. Kinda like having a speed boost on a racetrack, except it's invisible air molecules doing the job. So next time you hear a distant siren or a far-off shout on a hot day, know that the air temperature is giving sound the super A speed. It's a simple, everyday mystery solved by the physics of sound. If this blew your mind, hit that subscribe button so you never miss another mind-blowing fact. Drop a comment below if you've ever noticed a difference in sound on hot versus cold days, and tell us what you'd like to learn next. See you in the next one.